All right, I'll start recording. It's 2:04. We can't put it off for that much longer. I know, we're here. Hello, Zoomers. Can you hear me and see me okay? There's some thumbs. Excellent. Roomers, welcome. We're here. So I sent the TAs homework 5, which they're going to look at for you. My goal is to post it before Thanksgiving break. So that is your last big thing. If you want to get it done early and be done with this class, go for it. If you want to pretend like it doesn't exist until the day before it's due, go for it. I don't care. You all have your stuff. I trust you to plan your activities, your enthusiasm, and your efforts accordingly. But I will say that the homework is a good way to procrastinate on other things that are much more amorphous in nature. Like if you're not sure what you want to write or how this lit review is going to flow or what your topic's going to be for something, this is a much more constrained activity.
And fun.
And fun, yes. Yeah, the theme of homework 5 is Scrabble. So I'll just put that out there and I'll explain later because there's a story that goes with it. I have to make up 2 more formative assessments that are designed to help you get ready to do homework 5. So a little more scaffolding for that. Otherwise, that's it. I put up example 5, which we should hopefully be able to start today. If not today, then next time. And lecture 6, and that's it. So we are in the home stretch for sure, which is always nice. One way or the other, the semester will end. It is finite. So we just got to hang in until there. All right, am I forgetting anything logistics-wise? Oh, I know one more thing I was going to say. I am forgetting something. Next week, no class on Thursday. So take the day off, go home for Thanksgiving early, or just take a nap. Take a pick. Do your homework. Yeah, well, I intend to have it open by then. Let's put it that way. But we won't have been through all the stuff yet. But I know some folks like to work ahead. So. No office hours, no anything during Thanksgiving week. However, I will be working Monday, Tuesday, and likely most of Wednesday. So if anyone wants to meet with me for whatever reason, just let me know. And that's what I wanted to say about the schedule. Okay. So we have interactions to talk about, right? Yay! So interactions deal with moderation. That is the new vocabulary word for this unit with respect to the big picture. We are examining models designed to assess moderation. You may also hear the word mediation in the context, like mediation and moderation, or moderated mediation or mediated moderation. And yes, those are all 3 different things. Mediation and moderation are not synonyms. So interaction terms are moderation. Mediation is usually explained with some kind of triangle-looking diagram where you have a box here that's labeled X that is thought to cause another box called the mediator labeled M that is thought to cause the outcome Y. So that is a statement about why relationships are there such that after you control for your mediator, the direct effect of X and Y is different. That's mediation. Moderation is the effect of X different as a function of some other variable? Is this bad for you? Yes. Is it equally bad for you? No, it's worse for some people than others. People who have this characteristic have it worse. That's moderation. Or this treatment program is most effective for kids who have this background characteristic, but not for these kids. Those are moderation type questions. So I want to introduce vocabulary in terms of how we have to change the way we talk about slopes and their effects in these models, because this is where a lot of folks get it wrong, quite frankly, and I don't want you to be one of them. In models with interactions, it is very tempting to look at part of the coefficients and be like, well, this is not significant, therefore this variable doesn't matter. A moderation means it doesn't matter for that kind of person, but it could matter for a different kind of person. So there's a lot of sort of, I would say, messiness/inaccuracy in how people talk about moderation models, and I want to make sure those people aren't you. We're going to do it the right way. That's what we're going to do. So, and I promised to talk about this as if I never said anything on Tuesday, right? I promised? Okay, I hold my promises. So here's the idea. We are putting in a slope that is multiplying 2 variables that are multiplied together. The slope is called an interaction term. In terms of the terminology, what we used to call fixed slopes beta 1 and beta 2, these are now going to pick up the name main effect. to differentiate them from beta 3. So the slope of a variable all by itself, we're going to call main effect. In this example, there are two equally correct ways to talk about moderation. It's how the effect of x changes as a function of z, and it's how the effect of z changes as a function of x. Both of those are correct. So which one is the moderator is a choice that you have to make that's interpretation-based, not mathematically based. And I ran through this before, making the point that different ways of setting up models within the general linear family historically have had different defaults with respect to how interaction terms are specified. In ANOVA, the default is all interactions are included, and people tend to keep it that way. They don't trim the model down to remove non-significant ones. In ANCOVA, you are told that the C, the covariate, the numeric variable, can only have a main effect, otherwise you're violating an assumption. Just put in the interaction if you need it, and don't call it ANCOVA anymore as the solution. And in regression, there is no default. You choose which interactions to include and why. So main effects. Whenever you have an interaction, we got to keep the main effects with it. Otherwise, it does not actually indicate an interaction. It indicates some combination of both. The trick in talking about interaction terms correctly is not to talk about what they do to y. That is the instinct because it's a slope, and we're used to saying as x goes up, y goes up, or as x goes up, y goes down. Don't do that for an interaction term. It will just mess you up. What we're going to do is talk about what the interaction term does to the main effect slopes for the variables involved. So the interaction changes the slopes change y. That's how it works. It's like a trickle-down effect. So this is a new kind of conditionality that you have not yet seen this semester. And I want to introduce a taxonomy of labels that will help us keep this straight. So we'll start with this on slide 4. In most common linear models, not just this class, but all the advanced classes, structural equation models, anything of any higher level of complexity, fixed effects, meaning estimated constants, are either going to be some kind of intercept, meaning they give an expected outcome, conditional on whatever, or it's going to be a slope that gives you the difference in the outcome per unit difference in a predictor. Okay, so we're talking about slopes. The three kinds of slopes that you will encounter in standard linear models, I'm going to use the labels bivariate marginal, unique marginal, or unique conditional. In models with one fixed slope, there is no question as to what it means. Like if I have x predicting y, the end, the way I would talk about that is that the slope is bivariate, meaning it's only two variables at a time, not controlling for anything else, and it's marginal, meaning that it applies equally to everybody. So if I say the slope of x predicting y is 2, that too applies to everyone regardless of what other data you have about them. That's marginal. X predicting y all by itself means it's bivariate. So at this stage, like this is the same as a Pearson correlation if you have a binary variable or a numeric variable. If your model has more than one fixed slope, then each slope is unique, meaning controlling for all the other slopes in the model. So this is the effect of x after controlling for z. This is the effect of z after controlling for x, that idea. That was the last unit. If that predictor is not part of an interaction term, then I would further say it's not just unique, but it's marginal. Meaning, again, if the slope is 2, it's 2 for everybody. It's 2 after controlling for the effect of z is the unique part, but it's 2 for everybody is the marginal part. The new one, if your predictor is part of an interaction term, it is not only unique for its main effect slope, it is also what is known as conditional or simple. I did not make up these words. You believe me, right? I would never choose the word simple for something. It sounds offensive. And it's wrong, because like this is one of the more complex topics in linear models. There's nothing simple about this. So I would call it a complex main effect, but that terminology has not taken hold. Instead, I will go with conditional, meaning it is specific to the zero value of any predictor it interacts with. That's what conditional means. So if it's 2, it's not 2 for everybody anymore. It's 2 for people for whom z is 0. And as z changes, that 2 can become something else. So let's practice. We'll do some generic stuff and then some more specific stuff. And I'm going to post the version that I'm typing in after we're done here. Or you can feel free to type along with me. So in terms of labels, here are my 3 choices. We'll go through each of these models and try to label what kind of effect each slope is going to be. So for beta 1, I have the effect of predictor W in predicting Y. Which of these 3 terms would I describe the beta 1 slope as?
Bivariate marginal.
Yeah, and we can vote 1, 2, or 3. By the way, we can do like the fingers. That way the Zoomers can play along. Are there number icons? I know there's face icons and all kinds of other things. We got a 1.
You can type in a number.
You can type in a number, yeah. You got a keyboard. You don't need icons. I'm thinking like my son, where everything's an emoji or something. But you're voting 1. Another vote for 1. Zoomers, are we going to vote? Icons, talking, chatting. Yeah, it is 1. It's bivariate because there's only 2 variables. And there's no such thing as bivariate conditional. That's not a possibility. So it reflects the full relationship between W and Y, that's the bivariate part, and that is assumed to be the same for everybody. That's the marginal part. Now if I add some stuff, now I have a main effect only of W. I have a main effect of X, a main effect of Z, and I have an interaction of X and Z. So we got already voting. Okay, now W. Do we stick with bivariate marginal or do we change to 2 or 3 here? We got 1 vote for 2. Another vote for 2. Another vote for 2. Zoomers are voting 2. Yes, indeed. So now W is, after controlling for X and Z, how does W uniquely relate to Y? So it is unique. What makes it marginal and not conditional?
There's no interaction term.
Yeah, W is not part of the interaction. So if this slope were 2, it's 2 for everybody, period. So unique, marginal. Okay, X. How about the slope for beta 2? Bivariate marginal is 1, unique marginal is 2, or unique conditional is 3. Got to vote for 3. I'll give you a hint. It can't be bivariate. It'd have to be like 5 variate or something, right? 4 variate? That's what this would be. 4 variate. Quad variate? Yeah, let's just make some shit up. It's fine. Yeah. We got 2 votes for 3. Can't be 1. It has to be one of these 2 because we have a model with multiple stuff in it. Is that a 2 or a 3? Can't see. There's a 3. Okay. Yep. It is indeed unique conditional. Conditional. There. So unique because it is, after controlling for W and Z, what is the unique effect of X? But here's where folks screw this up. This is not the effect of X. This is specifically the effect of X when the other effect of X drops out. The other effect of X is buried in the interaction term. It's going to drop out when Z goes to 0. Then this is the effect of X. So long story short, beta 2 is how Y changes per unit X if Z is 0. For Z is 0 people, this is your effect of X. But for Z being anything other than 0, beta 4 is like a knob that's going to crank that slope of X up or down as a function of Z. So beta 2 is specific to z of 0. Beta 4 acts like a knob that adjusts that beta 2 slope as a function of z. Okay, with me so far? How about beta 3? What's my label for that one? Yeah, don't overthink it. It's 3, yeah. For the same reason, but in the opposite direction of conditionality. This is the slope of z only when x drops out. So this is the slope of z specific for x equals 0 people. And the interaction term simultaneously is going to crank the slope of z as a function of x. So it's doing two things at once. Beta 4 is adjusting beta 2 as a function of z. Beta 4 is adjusting beta 3 as a function of x. Both. Now the tricky one, the interaction term. That's a slope too. It's a slope that's multiplying two variables, but it's still a slope. We can eliminate bivariate, right? Because we just decided it's quadvariate. Is this interaction marginal or conditional? "50-50 shot. 2 or 3, folks. Got 1 vote from the Zoomers for marginal. Got 2 votes for marginal, 1 for conditional.
2.5.
No, I've got 2 or 1 yet, but those 3 haven't weighed in. 3? Okay, 2. It's 2 and 2. Someone's got to break the tie. So let me put it to you this way. We decided that x is conditional because x is also over here. Which means that this isn't just the slope of x, it's only just the slope of x when z is 0. Otherwise, I got to take both of these things into account. Do you see anything else in the equation that has both of these at the same time? That makes it marginal. So if you think of beta 1, I saw a couple people writing stuff down, so I'm going to go with that analogy still as a crank. Like you're taking your slope and turning it up and down. The crank works the same for everybody. The crank is marginal. What it is cranking is conditional. Because you got to know what the crank is set to know what that slope means. So this one is unique marginal as well. It is the effect of x and z together after controlling for w, but how the effect of x and z is moderated by this interaction is the same for everybody, marginal. Can you make a guess as to what would make it conditional instead?
When either is 0.
When either is 0 would make it so that these things become just the effect of that variable without taking into account this. But what would it take for this crank to become conditional on something else? Yeah, a 3-way interaction. Yeah, so if you had w, x, and z all together as a 3-way interaction, then this one would be specific to w equals 0. It would be conditional in the same way that this is conditional on this being 0, and this is conditional on this being 0. If there were a 3-way, this one would be conditional on the third thing being 0. I'm not going to make you do a 3-way interaction, don't worry. I used to in this homework. I did. And then I decided that that was a little crazy. Backed it down. But you will have 2-way interactions in your last homework, just 2. Okay, so then we get to this part. Let's do this again, because I promised that I would pretend like we hadn't done it yet. Stop it. 4 kinds of interaction patterns in the world. The interaction takes a main effect slope and either makes it more positive, less positive, more negative, or less negative. And if the answer is more, meaning the signs are the same, then the moderator is strengthening that slope as the moderator increases. If the answer is less positive or less negative, it's weakening it and bringing it closer to 0. That's it. Once you figure out which quadrant you're in terms of those 4 possibilities, which you can even say are nested within just the 2, more or less, you're done. So for this one, if beta 2 is my main effect slope of x is 10, and the interaction term beta 4 is 2, then I would say as x increases by 1, y increases by 10, specifically when z is 0. For every unit higher z, the interaction term takes this slope of x of 10 and makes it what by 2? More positive, less positive, more negative, or less negative? Which pattern is this? And why does it sound like there's an airplane taking off in this building all of a sudden? Did they decide the air conditioner needs to come back for an encore? I'll just talk louder. Which pattern is this? If I have a positive 10 and a positive 2, what's the interaction term of 2 doing to the 10? More positive. Stronger or weaker? Stronger. Yeah. So this means more x leads to more y. And if this were a 2, I would say even more so if z is higher. So if z is 0, the slope of x is 10. If z is 1, the slope of x is 12. If z is 2, the slope of x is 14. So for every unit of the moderator, the slope cranks up by 2. What if the slope cranks down by 2 instead? Which pattern is this? Less positive and weaker, closer to 0 as the moderator increases. What about if I start with a negative slope and pair it with a negative interaction? More, because they match. Negative, stronger. And last but not least, this one has to be less negative or weaker. Let's do a story problem. So this is the point in most standard regression textbooks. I'm trying to get it so it'll fit on the thing and make it big enough here. Come on. This is the point in most regression textbooks where they introduce centering for the first time. You already know how to do this. But here's why it really starts to matter. Let's say that, there we go, little bumps. I have an outcome that is student GPA on a scale of 1 to 100. So it's like a percent score of some kind. Let's say that I have a variable about parent attitudes about the importance of education. It's measured on a 1 to 5 scale. So this would be like the sum across a bunch of items, all on a scale of 1 to 5. We take the average, and that turns it into a 1 to 5 scale. Z for education level, let's say that's in years of education. Let's say that this is the model that I hypothesize. This would be consistent with the idea that the effect of education is different based on what attitudes your parents have, or the effect of attitudes varies by what education they have. Let's say that my regression output gave me these nice whole numbers to interpret. And the variables are included as is, okay? Beta 0, my fixed intercept. That's the expected y when all my x's are 0, right? That's what the definition of intercept is. By the way, that is always what the definition of the intercept will be, like throughout the rest of your lives. The intercept is the expected outcome when your predictors are 0. For what kind of person is a 30 expected GPA? I'll start you off here. Expected GPA for attitudes equals what?
0.
Can attitudes be 0 on a 1 to 5 scale? They cannot. What about education?
0.
So for somebody who never went to school and thinks education is so unimportant that they're literally off the chart, that kid gets a 30. Well, the intercept doesn't matter, you know, it's just the constant in the regression equation. We can ignore it, it's totally fine. Okay, cool. So the slope of attitudes is 1. How do I interpret that 1? I'll start you off. Change in GPA per something.
Change in attitude when controlling for education.
Controlling for ed is true, but there's more to the story. Controlling for ed is the unique part. Now we got to add the conditional part, because this is part of an interaction term. Who is this the attitude slope for?
People with no education.
Yeah, to make this drop out, ed would have to go to 0. So this is the effective attitudes among people whose parents never went to school. So this, by the way, this is that. That's what I'm trying to make sure that is as clear as I can make it. These are two different things. Controlling for education means this is the unique effect of this, like the part of the Venn diagram that only that predictor has. For education equals 0 is a step beyond that. It's not just controlling for, it is specific to. Because if you think about a slope changing as a function of some other variable, you got to know which one you've got. And it depends on where 0 is, and you're in charge of that. So one might be tempted to say, look at their output and be like, oh, 1 isn't significant, attitudes don't matter. They don't matter amongst this kind of hypothetical person, but they might matter for other kinds of people. What about beta 2? This is change in GPA per unit ed. Controlling for at. For what kind of person? Zoomers can play too. At equals 0, ding ding. So this is how education matters for people who are off the chart in their attitude score. It cannot, you are correct. The linear model doesn't care. The lines are going to keep going. It don't care. However, I would say that in terms of writing a results section of useful information, we are 0 for 3 in meaningful coefficients at this point. We are talking about people that do not exist, most likely. And they certainly wouldn't in a sample for a research study where at a minimum, you'd have to read the instructions probably, which would require some minimal level of education. So we're 0 for 3 in meaningful coefficients at this point. Let's interpret the interaction terms. I've got two potential interpretations here. If I think about attitude as the moderator, then my focus is on the slope of education as the unit of the sentence. So I would say something like, ed slope is, and all these numbers are positive, so we know this is a more positive scenario. Ed slope is more positive. I can't spell. Can I say pause?
Sure.
What's the end of my sentence? per what? Because note the symmetry here. Thing that we're adjusting, thing doing the adjusting. Thing that we're adjusting, we're missing the thing doing the adjusting.
Per unit attitude.
Yep, it's per unit other one. Yep, so the slope of ed is 2. As attitudes increases by 1, that slope of 2 becomes more positive by 0.5. The slope is what is getting changed by the interaction term. And it's always the other variable that is changing it. So if it's the slope of ed, then the moderation is per unit attitude. If I go the other way, at slope is more pos by 0.5 per unit, ed, the other one. So all in all, my model would create a predicted outcome for a person who does exist, let's say someone who has a 3 on the 1 to 5 scale and finished high school, so has 12 years of education. I can fill in values for attitudes, values for education, and then values for each of them multiplied together, and I can get a predicted outcome of 75. So in that sense, no matter what 0 means in my predictors, the model is still going to tell me that the predicted outcome for this kind of person is 75. The R-square for the model is going to be the same regardless of how I've centered. Nothing changes in terms of how well the model works as a whole, as a function of centering. What changes is the interpretation of the terms that are lower order to the interaction terms. That's what changes as a function of centering. So up to this point, we've seen this in the intercept, right? In your homework, if you get the residual variance correct as the first question for a section, you know that your model has the right stuff in it. The next question is usually fixed intercept. Do you remember why I asked you that? It's a check. If you get the fixed intercept right, that means you have the right definition for what 0 is in your predictors. Otherwise, the model would be right, but the intercept would be wrong. So in your last homework, and more generally in models with interaction terms, you should be prepared for your main effect slopes to change interpretations as they become embedded within interaction terms, because they're always going to be conditional on the thing they're interacting with being 0. So here's what the solution would be, back out of this here, if I centered these things at reasonable values. I have attitude centered at 3, ed centered at 12, and I carry that through the interaction terms as well. So my beta 0 used to be 30, now it's 75. That's because previously 30 referred to the predicted GPA for someone with 0 values. From this prediction right here, I know that if I fill in 3 and 12 as my new reference points, I should get a predicted GPA of 75. So that's why I know that this is here. So now, go back out, come on, ding. You can do it. PowerPoint's like, no, I'm tired today. I don't want to advance. There we go. So 75 is the expected GPA given attitudes equals 3 and ed equals 12. Beta 1. Previously, beta 1 was 1. Now it's 7. How did I know it would be 7? We got to work backwards. What does this mean now? This is the difference in GPA per unit attitude. That part gets me to what the slope means. What's the end of my sentence? 4. Who is this for? When does this become the only source of the attitude slope? What has to happen over here?
High school graduate.
Yeah, high school of 12 is when this zeroes out. Yep, so the Zoomers are saying at 3 and ed 12, it's half of that in this case, because we're focusing on the slope for attitudes. It's not conditional on itself, but it is conditional on education equals 12. Likewise, beta 2 changes interpretation. It was 2, now it's 3.5. Diff in GPA per unit ed 4. Who is this one for? At equals 3. Zoomers, very good. The interaction term didn't change. Coincidence or consequence? Is the interaction term marginal or conditional? What did we decide like 15 minutes ago or so? We decided marginal, meaning it's not conditional on anything, it's not affected by centering. So the interaction term is how the slope gets cranked by the moderator, either one. The cranking is constant across people. So it's the same interpretation regardless of where the main effect slopes start. They're just starting at more reasonable places at this point. Okay, so if I go back to the previous slide for a moment, make this big, I can anticipate what the new slopes would have been by working with this interaction term. So I know that beta 1 is 1 if education is 0. If I want to know, if I plug in education 12 here instead, 12 times 0.5 is 6, right? Just checking my math here. 6 plus 1 is 7. So that's how this became 7. Likewise, I used to have a 1 here, or I had a 2 here, excuse me, and I want to move from attitude of 0 up to attitude of 3. 3 times 0.5 is 1.5, plus 2 gives me to the 3.5. So the model tells you what the slopes would be for any value of the moderator, like it's in there as a linear combination. The ones you happen to get are specific to how you defined 0 for the predictors. And that's where you get control of that. Do you want to talk more examples, or do you walk through code to do stuff? I could go either way. What do we think? Code? 1 vote for code, 2 votes for code. Okay. I also have more examples from story problems to try and help us think about interactions conceptually, so we can do those as well. So more on linear combinations. Up to this point in the class, you have learned how to do linear combinations to get predicted outcomes, like for the non-reference group. She's like, I have not learned this. You have done so. I have evidence that you have done this. How is that? It may not be in here anymore, but you have done so, and you have references to come back to for the rest of your life. You know how to make linear combinations to get predicted outcomes. You've done this to get differences between the non-reference groups, like the mini golf versus regular golf, that whole thing. You've done this to compare the size of slopes, sort of more generally. So here is yet another use case. So we'll start with predicted outcomes first, and then we'll talk about how the code has to change it into a predicted slope. So I have examples here using Stata code and examples here using R code. It's doing the same thing. And I'm trying to color code this to make this as least painful as possible. So if I'm creating a predicted outcome, my job is to fill in the values of the predictors that I want the predicted outcome for. So for instance, if I want, what would GPA be for somebody whose parents have attitudes at the top of the scale of 5 and they have 16 years of education? So here's my equation in which I have centered education and attitudes. So I have a 1 here and I have a 1 here because every prediction of an outcome starts with the intercept. At a minimum, you need the intercept, because that's the expected outcome when everything else is zeroed out. You at least need that much. If I want a predicted outcome for somebody with attitudes of 5, what do I type here and don't say 5? Yeah, another number question. Got 1 vote for 2. Lots of votes for 2. You are correct, because 5 is 2 more than 3. And it just like reformatted itself without my permission. I love it when it does that. So that means folks who use R, your 2 would go here. Second spot. If I want a prediction for somebody with education equals 16, what do I put here? Yeah, 4. And if I want a prediction still for somebody who has attitudes of 5 and education 16, what do I put here? Yeah, we're going to start running out of fingers. I put 8, because 2 times 4 is 8. Remember, I told you at the beginning of this semester that the thing that make this hard is not the math? It's not the math. It's the coding and the language and the concepts. That's what makes this hard. But we've all gotten very good at this by now. So I put my 4 here. I put my 8 here. Cool. Let's do it again. If I want attitudes of 1, what do I put here? Yeah, -1. If I want attitude or education of 9. Oh, what is it? Oh, did I do it wrong? Yep, I did. Thank you. -2. I can't do math, as it turns out. I told you I was going to be a psych major. We didn't need math. What do I put here for education equals 9? Yeah, -3. And what goes here? Negative or positive? Positive. I guarantee at least one of you is going to mess this up and send me a question about it. It's very easy to forget the basics when you're trying to solve code, but don't forget the 2 negative numbers multiplied together create a positive. Last not least, we got -2 in here. We got -3 in here. And 6. Question?
Yeah. If you don't trust yourself to multiply, could you have put times -2 times -3 instead of putting 6?
I think you can.
I
Yeah, so the question was, can you like write essentially what you're asking it to do in here as an operation? Stop that! PowerPoint's resizing my things. I think you can. I'm not 100% certain on that.
okay.
But it seems logical because you're just
It
writing
does,
out
but
instructions.
But because Stata's kind of weird. I know in R, I'm pretty sure you could do like the 2 times 3 inside of your statement.
Yes, I think there should be a way to make that happen, is the
Okay.
short answer. I just haven't really tried.
Okay, don't worry,
But-
I'm just
so-
curious.
Last but not least, what goes here for 3? 1, we got these. What goes here for education of 20? 8. And the end result would be 8, and so forth. So this one's not so bad, right? Now, predicted slopes. There is a 3-step process to figure out what a slope is for any level of its moderators. Step 1 is find all the terms that have the variable the slope is for. Step 2 is to factor out that common variable the slope is for. Step 3 is to compute the result that is left in your code. So we're still not doing anything by hand, by the way. So let's walk through this step by step in this example. So if I want the attitude slope, step 1, find all the spots in this equation where attitudes is mentioned. So that means right away, I cross out beta 0. It's not attached to attitudes. I need beta 1, so I'm going to bring that down here. I don't need beta 2 because it has nothing to do with attitudes. I do need beta 3 because attitudes is embedded in there. So I got this much. So when you're writing code to execute these steps, keep in mind that only terms that have that predictor in it should be in your code. Those are the only possible things that would be relevant. The intercept will never be relevant in creating a predicted slope. And if a term doesn't have that variable that the slope is for, it's not relevant. So now I've got all the things that are possibly contributing to what makes the attitude slope. Next step, do the same thing for education so you can see the pattern. I have the main effect and the interaction term. I don't have the other main effect because it's not relevant to that slope. Then we factor. So I pull attitudes out of each of these terms, stick it at the end, and then what's left are the ingredients by which I get the attitude slope for any level of education as the moderator. Likewise, if I pull education out and stick it at the end, what's left is the linear combination that gives me the education slope for any value of attitude as the moderator. So then this little embedded equation hopefully makes it a little clearer why we would interpret beta 1 as the attitude slope specifically when education equals 0 is because that's when the second term drops out. Likewise, beta 2 is the education slope specifically when attitudes is 0, which is when this second term drops out as well. And by the way, if you needed to in life, and I don't know why you would ever need to do this, here's the formula by which you can compute a corresponding standard error for your model implied slope. Don't do this, but just there's math, you know. All right, let's do the math in Stata and R. It's kind of like a puzzle. It's fun. No, it's not time to go yet. I'm sorry. Remember, we're contractually obligated to be here in learning. But I understand. By the way, next semester, would you like to know when my regression class is going to be offered?
8 a.m.
Worse.
Oh, no.
4:40
PM?
to 7:30 p.m.
Oh
on
my
Mondays.
gosh.
May I say something?
Thoughts and prayers,
7,
please.
So it's all at once in one.
A 3-hour block
big-ass
over
chunk.
dinner.
Oh my gosh.
May I share
Yeah, Michael
something?
teaches at night too.
Yes, so I have a class, I have 2 stat classes, one of them starts at 7 p.m. It goes, and we meet for an hour. The other one starts at 9 p.m.
I'm in bed then. What are
Yeah,
you
9
doing?
o'clock doesn't exist, dude.
It's at least not when I'm conscious. You know, like,
Yeah, no.
I
So-
have students interacting the whole time, so, you know,
well,
they're
I
awake.
guess that's what matters, right?
They're on Zoom, so maybe they're having a couple of drinks, you know.
Whatever gets you
Just
to
a
the
while.
class.
Well, we could make it like book club. Isn't book club just an excuse to hang out with your friends and drink wine?
Yes.
I think I've been doing book clubs wrong.
Well, you need to read enough of the book that where you can start the conversation, and then when it turns after there's enough wine, then you don't have to pretend you
I
read it
think the
anymore.
limit at book club is 15 minutes.
Yeah, so we could have like maybe regression club, and you know we just take turns bringing the wine and making it more fun. Well, to be fair, it's hybrid.
Kendall
So
and I will
folks
start
on Zoom.
first, and I'll let you know how it works out.
yeah, see the folks on Zoom right now could be having regression club of their own. How would I know, right? But does that make you feel better? Right, that you only have to be here for an hour and 15 minutes at a stretch in the middle of the day? Okay, yeah, I'm gonna have to figure out how to be energetic and cognitively capable after 4:30 in the afternoon.
More Mountain Dew.
I think it's gonna require you to alter your Mountain Dew pattern.
Yeah, I'm gonna have to become a night person, I think, or something, at least on Mondays. But anyway, that's not a today problem. Today problem is learning how to write code for this stuff. Yes, and this, by the way, is the kind of thing you're gonna practice in your formative assessments before you do your homework. So, because this is where things get a little tricked up sometimes. Okay, so our job here is to not create predicted values. Our job is to create predicted slopes. So when I go into each of these lincoms, for instance here, note that I've tried to help you out by starting all of them with a 0, and likewise there's a 0 in every spot in the corresponding R code. That is because the intercept will never go into a predicted slope, ever. So what we are filling in values for the first two lines is for this term right here. That is how we model built the slope. So we need to refer to this to figure out what values to plug in here to get the slope for whatever level of education we're trying to specify. So if I want the attitude slope if education equals 10, what goes here is a 1. The reason for that is this variable and this spot right here in R, second spot, corresponds to beta 1. Beta 1 does not have a multiplier. We need one of them. Because at a minimum, to get the attitude slope, we need the attitude slope. We got to start somewhere. So this goes to 1. What goes here? This refers to beta 2 as the main effect of education. Got 1 vote for 0. Is beta 2 in here? It is not. Because we're talking about the slope of attitudes. It has nothing to do with the main effect of education. So this is actually 0. Where education goes is in the spot for the interaction term, because that is the slope that multiplies education in creating another slope. So if I want education of 10, then this goes to -2, like that. So I'll fill in the values down here for completeness as well. 1. By far, this is the #1 mistake folks make when they're first doing this. By far. Because it's really tempting to be like, well, but if I want the slope for education equals 10, like, doesn't 10 need to go here? It doesn't. Because this is just the effect of education, irrespective of attitudes. We're focused on attitude slope specifically. So the moderation happens through the interaction term. That's where we stick in the value of education that we want the attitudes slope for. So if we do the next line down, what if I want education equals 18? What goes here? Yeah, this is still a 1, because we're still just needing one of those. How many main effects of education do we need? We need none. And then what goes here? Yeah, I'm doing the math. 6. There. Okay, are you ready to try it the other way? So now we're doing this one.
Did you want to put the code for
Why not? We'll kill a little time.
let it sink in a minute?
Yeah,
Everybody start thinking about the next one.
yep. Good idea. There. Now we want ed slope. So in the original equation, only stuff that has ed attached to it is carried forward. If I take out education of each of these pieces, what's left are my ingredients. So now if I want the education slope for attitude equals 2, what goes here? How many beta 1s do I need now if I'm trying to get the education slope? I need none. And I'll do this one too. So for the same reason this main effect was shut off, because we're not talking about the main effect of ed, we're talking about attitudes. In this one, we're not talking about attitudes, we're talking about ed. Same deal. What goes here? How many beta 2s do I need? I need just 1. Do I need just 1 down here too? Yep, no matter what, you at least need the slope that you're trying to find. What extra stuff you need beyond that is dictated by how many moderators it has. If I want attitudes equals 2, what do I put here? Yeah, -1, yeah. And if I want attitudes equals 5? Yep, 2. Very good, Zoomers. So this is the tricky part to me. When you are plugging in these two values, you are thinking about what levels of ed are you trying to get this prediction for? Because your prediction is for the attitude slope. That same interaction term now, in these instances, is what values of attitudes are you plugging in? Because you're trying to get the ed slope for that level of attitude. So which of these two variables you're filling in for depends on what the point is of the statement. What was the variable you got factored out? That's the one that gets the 1. You can ask for, in Stata, you can actually ask for these things using margins and like roll through any combination. Like you could ask for this, like 30 of them. What if it were 1? What if it were 2? What if it were 3? What if it were 4? Like you can get all of these things. In R, I have not found a way to do that that isn't painful. But I'm sure there is one. So this is a technique that I did not learn until I was on the tenure track. Like how to ask for these kinds of linear combinations and simple slopes was something I just wasn't taught. What I was taught is a workaround. So let's say that you don't know how to do any of this stuff, but you know how to run a regression model. If you needed to get, say, the simple slope of attitudes for somebody with education of 16, how could you do that by brute force using just regression? Can you think of a way that you can hack this to get that answer? So in this model, this beta 1 right here is going to be the slope of attitudes specifically when education is 12, because that's the point where this interaction drops out. How do I get beta 1 to represent the effect of education at 16 instead? If I don't know how to do any of that stuff down there.
Recenter.
Yeah, you recenter. That's what I was taught to do. Because if I change what 0 means for education, my beta 1 is going to change to match it.
That's a nightmare.
That is a nightmare. You are correct. Because then, well, what if I want to have the education slope for attitudes equals 5? Now I got to recenter that one, and now I got to run 17 permutations of the same damn model to get all the pieces that I want. And people are laughing like, have you had to do this before? Have you seen this? Yep, Welcome. Join in. The water is warm. It could be worse, though. So that was what I was taught, essentially, is run all the permutations, recentering every time, which to me, yeah, you got to, like, it gets very tricky to keep track of that. If you know that you need predictions for certain kinds of people, just ask for them. One analysis. And if you do yourself a solid and label everything that you're doing for your future self, then it will make it easier. So I've had to teach interaction terms pretty much at the beginning of every workshop I've ever given in my life, because I found that most people don't know what to do with them. And all of the higher level models, multi-level models, longitudinal that I'm typically focusing on in the workshop need interaction terms as a base. I once had someone come up to me and she said, she was just like, oh my God, I wish I had had this a month ago. She spent, I don't even know how long, writing out 90 versions of a regression model to get the slope at like 30 different levels of some moderator because she didn't know how to do it otherwise. And now I look at that and I'm like, that's one regress line and that is one margins line in Stata. And it will spit everything out for you. So there are situations in which writing all of these out is more work than I want to do, and I just need to switch one thing and I'll switch the whole model. So as an example, if I have an analysis differentiating a treatment group from a control group, and I want to put in a whole bunch of interactions with treatment, like did treatment work differently about this? Did treatment work differently about this? All of the main effects of those other predictors would be specific to the zero group, if that I set it up as 0 and 1. But if I want to know what happened in the treatment group, then an easy way to answer that question is just to flip the 0 and 1 and rerun the model. Because then I get everything specific to the treatment group in one model. The original model would have everything specific to control, and the interaction terms would work the same either way, just negative if you flip the coding. So there are situations in which hacking it by recentering can be more efficient, but in general, I would not. I would run programming statements that take pieces of the model and create the terms that you want. So, okay. How are we doing? Do you want to do like maybe 1 or 2 stories? Have you had enough of code for today? Maybe? Maybe? Look, no numbers, just words. Let's get some practice doing moderation hypothesis. So each of these is an example of a question that someone had asked me before, and I thought I would steal those and bring them here. So during the pandemic, one of the students in an earlier version of this class gave me this example. They had a hypothesis that camera use on Zoom is related to better grades, but less so in larger size classes. That's the hypothesis. So my task for you and us to work together is to try to figure out what the pattern would be of the results to be consistent with this hypothesis. So first what the model's going to look like, and then what the pattern's going to look like. So if I wanted to build a model to answer this question, I'm going to abbreviate beta for B in the interest of time. What do I need in my model? What would my predictors be of grades as my outcome?
Camera use.
Camera
yes or
use. So I need something for camera. What else?
no? Class size.
Class size. Am I done? What else do I need?
Your interaction.
Okay. Now, if this person is right, I have P for positive and N for negative. I'm going to switch the labels here. Beta 1 is the main effect of camera use. What do I need to know to interpret what this means? This is the effect of camera use for whom? When is beta 1 the only thing that dictates the effect of camera use?
Wherever your class size is centered.
Yeah, I need to know what 0 means in class size. Can you have a class of 0? Pretty sure that's not a class at that point. That's just a monologue. However, if you look through the course catalog, you will see classes of like 2 people. There's a class in our program right now with 3 people in it. So 0 is not too far off in some cases, but let's say that we centered this such that class size is centered like medium-sized classes. So the reference for size is some medium number, the mean. Okay? What do I need to know to interpret the effect of size? This is the effect of size for...
Whoever the camera group is 0.
Yeah, whenever camera is 0. Let's say that 0 means no camera. Seems intuitive. Okay, so knowing that then, do you think that in medium-sized classes on Zoom, that camera use matters? Does it help your grades or hurt them? I say as the Zoomers have no cameras on. It's okay, I'm not mad. Just pointing out the irony of this situation.
It helps.
It helps. P for positive, damn it. Now, is being in a larger class related to your grades? I don't know, you say yes, you say no, or it's negatively related? I don't know.
Throw in the teacher effect and I'll give you an
Yeah,
answer.
so this would be amongst students who have their cameras off specifically. So I'll say, let's go with the negative effect there, why not? Now, if this hypothesis is correct, that camera use is related to better grades but less so in larger classes, what direction does this coefficient have to be to make that work? We're doing all sorts of creative gestures here. We got up, we got down. So positive camera use to be less important in larger size classes, yeah, the interaction term has to be negative. Because what that would mean is that the effective camera use is less positive as class size increases. So for every unit increase in size, like for every extra person, I guess, your camera slope would become less positive by this number. Now I could go the other way too. If you think that there's a negative effect of class size, a negative interaction would mean that that effect is stronger if your camera's on. I don't know if I would expect that, but that's what that would mean. So a negative and a negative creates a stronger effect. A positive main effect paired with a negative interaction creates a less positive effect. Ba-doom. Okay, so I've got a few more of these things we could practice next week, but not today. You will see this a lot in results sections, that moderation was significant. And like that's the end of their sentence. It's like, no, what kind? Did you get it in the right direction? Because if you found the opposite pattern, right, if this were a positive number, then you would have the hypothesis wrong, but moderation would still be there. So figuring out what the signs would be if you're right and then matching that to what happened is important. So, all right. So let's see what's going on next week. Do we have anything due? I think we do.
Homework.
Homework, that's right. Yep, there's a homework due on Monday. How's that going, folks? Let us know if you need help. Office hours next week as usual. No class on Thursday, though. It's the Thursday before Thanksgiving break. Everyone's going to be at a conference on their way home or otherwise too tired to come. That's what I've learned from years past, so we're just not coming.
Does that mean that we are or are not holding office hours Thursday, Friday?
That is up to you. I assumed that you would be, unless you wanted to tell me otherwise, in which case I can add it to the thing.
I'm only inquiring because of a statement made in the previous class.
Yes.
Yeah, I'll have my regular office
Yeah,
hours.
me
You
too.
do? Okay, yeah, I was planning on it
that,
too, the
but
whole
I
week.
didn't want to.
Okay, so yeah, so just no class on Thursday.
There's so many conferences right now.
There are.
Like this week and next week, and they're like the big ones.
Mhm.
Not like.
Yeah, I know of 5 off the top of my head in different disciplines, so that's where, like, no one's gonna be here, so. All right then, let us know if you need help with homework. Thanks for being here. See you Tuesday. Have good weekends. Bye for now.